Question 2, part 2. You get the first mark by using the conjugate, square root 6 plus 5 over square root plus 5. The second mark is for the multiplying, simplifying. Notice that that last mark, you must have the negative sign in front of the fraction or on top of the fraction. See my theory note out to the right? You can't have a negative sign on the denominator. Now in question 3, again, we're going to use our conjugate and end up with 2 minus square root 3. The algebra in question 4 looks complicated, but what you're doing is exactly the same as over in the theory note. When you're adding a pair of fractions, or in this case subtracting, you get a common denominator. For my example, it's 4 times 5, and for the question, it's 2x times x minus 2x minus 1. And you get your equivalent fractions by multiplying diagonally. Have a look at the theory note because it's the same procedure for doing the algebraic fraction. After that, it's just a matter of being very careful with signs, expanding and collecting terms, and simplifying. The final mark was to leave it in the denominator in factored form and not as a cubic expression. Don't multiply it out. And question 4, part 2. It's a complicated version of what is really quite simple. Again, if we see our theory note over there, 2x cubed all to the power of 4, you bring your power of 4 in, it becomes 2 to the 4 and x to the 3 times 4. And that's what they've done on the top line of their question. 2 to the 2n plus 1 and 3 to the 2n plus 1. And then when it comes to simplifying, you'd simplify the question the same as you'd simplify my one in the theory note, x squared over x5, you subtract powers. So when we subtract the powers of 2, you've got a power of 2n plus 1 and a power of 2n plus 4. When you subtract them, 2n plus 1 minus 2n plus 4 is negative 3. And again with the powers of 3, subtract those powers and we get 3 squared. The final step, 2 to the negative 3 is 1 over 2 to the positive 3. 1 over 2 cubed, 8. So 9 over 8. In question 5, the key is to recognise 4, 8 and 32 are powers of 2. 4 is 2 squared, 8 is 2 cubed, and 32 is 2 to the power 5. We multiply powers between brackets, so you get 4x, 3x minus 3. And then in step 4, all we've done is taken the powers. 4x plus 3x minus 3 equals 5. Remember, when you're multiplying, you're adding powers. On the left-hand side, you're adding 4x plus 3x minus 3. And then we solve and get x equals 8/7. Dropping down to question 6, part 2. We get the equation, we get the gradient of the line by rearranging the equation to y equals. So we're starting with 3y minus 5x minus 3 equals 0. Take the 5x across, becomes positive. Take the 3 across to the right, it becomes positive. Y equals 5/3 x plus 1, gradient's 5/3. And so in part 3, the perpendicular, negative 3/5. Now in part 3, it said in ax plus by plus c. So you have to have it in this form, plus 3x plus 5y minus 39. For this question, there's no other alternative. X has to be positive, and it has to start off with x, then y, then number. Part 4 is following on from part 3. In part 3, we're told that b is where the line crosses the x-axis. Anywhere on the x-axis, y equals 0. So our equation, 3x plus 5y minus 39 equals 0, we want to know x when y equals 0, so 3x minus 39 equals 0. B equals 13, 0. And then part AB, it's Pythagoras, or what they call the distance formula, and we can just leave it as square root 136. In question 7, to find the equation of line AD, all we know is that it's perpendicular to the line AB and it goes through 2, 6. So we start by getting the gradient of line AB, change in y over change in x, -9/3, or -3. So the perpendicular line, AD, is gradient of 1/3. And we can now get the equation, x plus 16 equals 3y. In this case, it could be any version of the equation. It didn't ask us to do it in any specific way. For part 2, we'll use simultaneous equations. You have to rearrange the equations so they line up x, y equals number, just like I've done on a theory note. And then you can use whichever method you prefer. The simplest one is just to enter it into your calculator. And our solution's 6.5, 7.5. The next thing we're looking for is point E. Now for point E, we can do it by vectors if you like. So firstly, we've got this parallelogram, ABCD, ABCE. Now from point B across to C, from B across to C, it's across 3 squares and up 6. That same vector from B to C is the vector from A to E, across 3 and up 6. And so E is 512. So that's what they say in the answers. Use the vectors. You don't need midpoint, just use vectors. The vector from B to C is the same as the vector from A to E.